how to calculate the list. Well, this is the center of gravity, and the center of gravity is at the center line. We are looking at the ship in transverse direction. Transverse direction means in port and starboard direction. If we look the ship from aft, this side will be my starboard side and this side will be my port side. So weight will act vertically downward through center of gravity like this. And if the vessel is floating at some draft, say for example, let me just mark here, if the vessel is floating like this at some draft, the geometrical center of this underwater volume is going to be the center of buoyancy, say somewhere here, and a force of buoyancy will act vertically upward through that. The vessel is called upright. Upright. Now let us consider the scenario where a weight, let us assume this weight is shifted from this position 1 to this position 2. Well, the center of gravity of the ship will also shift in this direction, only G to G1. As we can see carefully, this GG1 will have two components. This GG1 will have two components. One, the horizontal component, which is GGH, and another one is going to be GGV. This is the vertical component and this is going to be the horizontal component. Well, if it is shifted like this force, that is the weight force, will shift from G to G1 like this, and this will make a list movement. And because of this list movement, vessel will start inclining in a transverse direction. So we'll have transverse inclination, simply because the center of gravity is shifted from G to G1. Well, this force of buoyancy will also follow like this. Initially it was here. Now it will continue moving, and it will stop and directly come below G1. So G1 and B1, they will be in the same line. So B1 is the new center of buoyancy and G1 is the new center of gravity. Now this new force of buoyancy will cut here this center line at M, which is called meta center, and this G was here, which is shifted to GG1, and this will have two components, GGH and GGV. So this is GGH in this direction and this is GGV. Well, if we see carefully, this GGH is going to be equal to GG1. Let me just put it this way. So GGH is going to be equal to GV and G1. So we know that from the formula, from basic trigonometry, this is theta and this is going to be a right angle triangle. This angle is 90 degree. So tan theta is going to be GV G1 divided by GVM. Now, since GVG1 is equal to GGH, so we may write like this: tan theta is equal to GGH and H divided by GVM. This is GGH. Well, the horizontal shift of center of gravity in this direction, G to GH, can be calculated with this formula, W into D divided by capital W, and this W into D, it is nothing but list moment. Weight multiplied by distance will give me the list moment divided by W. And we should also note that this GGH, the horizontal shift in this one, let me just mark here, the horizontal shift in center of gravity will affect the value of list moment GGH. This one will affect the list moment. Now tan theta can be written like this: list moment divided by W into GVM. Now this GVM, we consider the GM with the vertical shift of center of gravity. Okay, now we should also note that GHM, this horizontal one, will affect the final list moment and the list angle, and this vertical shift will affect the list angle. So we can find tan theta like this. Tan theta will be final list moment divided by WF into GMF, and for sake of clarity I have taken list moment as final list moment, WF as final, and GMF also as a final. Now let us consider the list moment. Well, suppose this is weight W and its distance is D. If we load this W weight here like this and its distance is D, the horizontal distance I'm considering, so the list moment is going to be W into D, and this is the center line. So W into D, 10 meter on starboard. Similarly, if I discharge something from starboard like this, if I discharge this weight, so what happens? So if I discharge this weight, my list moment will be W into D, 10 meter on the port side, because that will create the port list if I discharge from starboard. So now let us consider the scenario. I shift some weight from here to here, from starboard to port. So let me just put it here, from starboard to port. So first let us consider I pick up this weight. So this is as good as I discharge the weight. So list moment will be W into D1. Similarly, when I shift this weight, so I discharge from here and I put this weight here, the list moment 2 will be W into D2, where D1 is the distance of shift from this, and D2 is this distance. So D1, this is the center line, so the total distance will be D1 plus D2. Well, how to find the list moment? We will just add, and both are port, so we will add. If they are of the different name, then we need to subtract. So W into D1 plus a W into D2. So this gives me W into D1 plus D2, and D1 and D2 is nothing but W into D. So we have this list moment towards port. So it gives a very interesting relationship that if I shift anything from this place to this place, from starboard to port, this way or this way, this will create a list moment. If I shift from starboard to port, this will create a port list moment. And similarly, if I shift something from port to starboard, maybe here, maybe this side, so if I shift something from port to starboard, I'll get a starboard list moment.